Tesla Bot Gen 3, the future of home robotics. Under $10,000, Tesla's Optimus Gen 3 robot could soon become the world's most popular household assistant, and all for under $10,000. Set for release as early as next year, this latest version boasts significantly improved hand dexterity and smarter AI learning capabilities. That means it can smoothly take care of everyday tasks like cleaning, carrying items, or even assisting the elderly. Elon Musk says Optimus has 4 key strengths that give it an unbeatable edge over the competition. So, what makes Tesla poised to dominate the home robotics market in the coming years? Before we dive in, help us hit 10,000 subscribers. It's a huge motivation for us to keep bringing you exciting updates on Tesla EVs, the Model Q, and breakthrough tech like Optimus. 1. Stability and mobility. Tesla versus the competition. Let's start by comparing Tesla's Optimus with Figure 02 to understand how far humanoid robots have come, especially in terms of walking and balancing, which have historically been major challenges. When Tesla first introduced the Optimus project in August 2021, many experts were skeptical. Boston Dynamics, after all, spent over 15 years tackling the same technical hurdles. But instead of seeing these as barriers, Tesla leveraged modern AI to turn challenges into opportunities. One of the toughest problems in robotics has always been balance. Older systems relied on complex calculations from multiple sensors, continuously adjusting joint actuators to respond in real time to changing conditions. This led to early robots, like Honda's Asimo and Boston Dynamics' Atlas, being tethered to safety rigs during testing to prevent them from toppling over. But everything changed with reinforcement learning. Unlike older methods that depended on inverse kinematics, an approach that involves calculating precise joint angles and contact forces, known as the zero moment point or ZMP, AI-based learning allows robots to adapt and improve with experience. The old ZMP method was accurate but slow, sometimes taking up to 200 milliseconds to respond to changes in terrain, according to a 2019 MIT study. Critics also questioned Tesla's choice of a humanoid form over simpler wheeled designs, which are easier to stabilize and more energy efficient. But new tools like Advanced Inertial Measurement Units, IMUs, similar to what smartphones use, but far more precise, combined with millions of AI-driven simulations, have made stable bipedal movement not only achievable, but practical. A 2023 NVIDIA study revealed that a robot could learn to walk reliably after 25 million virtual steps, just a few weeks of simulation. If the simulated environment closely mirrors the real world, only a few hours of real-life tuning are needed to transfer that ability. And that's exactly what happened. Robots didn't just learn to walk, they learned to run, jump, play sports, and navigate rough terrain. Boston Dynamics' Atlas robot took more than a decade to perform advanced movements like running and flipping. In contrast, Figure 02 achieved smooth, natural walking at 1.3 meters per second just 18 months after development began. Meanwhile, Tesla's first Optimus prototype in 2022 could only manage a stiff, cartoonish shuffle at under 0.5 meters per second. It wasn't much better than Figure 01, which struggled to stay balanced while standing still, constantly shifting weight between its legs. But in just a year, the progress was dramatic. The updated Figure 02, released in late 2023, walked confidently, reacted reflexively when pushed, and could sit and stand smoothly. Milestones that seemed far off just a year before. Tesla hasn't released new Optimus footage since early 2024, but Elon Musk confirmed in a live stream that the robot is now capable of walking around Tesla factories, delivering items, and performing real tasks with its hands. Given Tesla's rapid development pace, just as we saw with their electric vehicles, there's a good chance the current capabilities of Optimus are already far beyond what we've seen publicly. We're also seeing similar progress from other robotics companies. China's GR1 robot from Fourier Intelligence and UB Tech's Walker X can now run, jump, and even perform flips. GR1 has hit treadmill speeds of 2 meters per second, which is comparable to a fast human walk. All of this suggests that stable bipedal motion is no longer the cutting edge. it's becoming the standard. Even affordable robots like the $3,800 Unitree H1 can now stay balanced when pushed or navigate sloped terrain, clear signs of how far robot mobility has come. Once again, if you're enjoying this content, please help us reach our next goal of 10,000 subscribers. Your support keeps us motivated. Thank you. 2. Dexterity and skill. Why Tesla's human-like hands matter. When Tesla first revealed the Optimus humanoid robot, some robotics experts were quick to criticize its human-style hands. They argued that using simple tools like clamps or suction cups, common in factories, would have been cheaper, more reliable, easier to produce, and far less complex to control. From a traditional manufacturing perspective, they weren't wrong. But what critics overlooked is that Tesla isn't building a typical industrial robot. Unlike machines designed for one specific task, a household robot needs to handle a wide variety of everyday situations, just like a human. That means its hands must be incredibly versatile, strong enough to grip a metal pipe, yet gentle enough to pick up an egg without cracking it. This level of precision and adaptability requires a far more advanced design. In the past, achieving that kind of dexterity involved writing complex control algorithms and manually programming every motion, an approach many experts thought Tesla should avoid. What they didn't expect was how quickly AI would change the game. Thanks to neural networks trained through millions of simulations, many of these tasks can now be handled automatically. Today, Tesla's Optimus can pick up a water bottle, type on a keyboard, and even fold laundry, actions that once required specialized robots and high-end software. In recent demos, Optimus showcased the ability to adjust its grip force in real time based on the weight and fragility of different objects, a task that older robots often failed at. Mechanically, this used to be a big challenge. Early humanoid hands couldn't fit the motors needed to move fingers directly into the hand, so they used tendon systems connected to actuators in the arms. While this worked, the tendons would stretch over time, reducing precision and reliability. But new innovations, like Tesla's compact brushless motors and AI-powered feedback systems, have turned this problem into a workable solution. Now, Optimus can automatically compensate for tendon stretch, making its hands both accurate and dependable. The second-generation Optimus now has hands with 11 degrees of freedom, more than double the 4 in its first version. Tesla is already working on Gen 3 hands with 22 degrees of freedom, powered by an advanced tendon-driven design. For comparison, most modern robots still only have about 5 to 10 degrees of freedom in their hands. Some competitors have taken notice and moved fast. For example, China's Magic Lab managed to replicate much of the Optimus hand design just 6 months after Tesla shared the blueprints. And Figure AI's latest model, Figure 01, now features hands with 19 degrees of freedom, enough to fold clothes and even use scissors like a person. Of course, with progress happening so quickly, trying to declare a winner now may be premature. Within just a few years, other startups like Sanctuary AI or Fourier Intelligence could match or even surpass these designs, if they invest the resources. But the real race isn't just about who has the most advanced hand. It's about which company can scale production, improve reliability, and integrate the smartest AI systems. And here, Tesla has a clear lead. They're already mass-producing actuators for both cars and robots, have deep pockets, and a world-class AI team. In 2024 alone, Tesla invested over $1 billion into Optimus development. They're also using their gigafactories to streamline the supply chain, drastically cutting production costs, something smaller companies can't easily replicate. That said, competition is heating up fast. Dexterity is no longer Tesla's exclusive strength. It's quickly becoming standard across the industry. The real differentiators now are scale, software, and system integration. In this rapidly evolving field, even small breakthroughs can shift the balance of power. The rise of household robots. Tesla. Bot is changing the game. For years, experts believed industrial robots would dominate the market, while household robots would take much longer to become practical. One big reason: price sensitivity. While factories are willing to pay a premium for 24/7 performance, everyday consumers are much more cost-conscious. But things are changing, faster than anyone expected. Tesla's Optimus Gen 3 is directly challenging all those old assumptions. This latest generation of Tesla's humanoid robot marks a major leap in both AI and mechanical engineering. But more importantly, it's bringing us closer to a future where robots can serve as universal household helpers. Elon Musk has made it clear, the long-term goal of the Tesla bot isn't just factory automation, it's to put a helpful, capable robot in every home. And with Gen 3, that vision feels more realistic than ever. So, what's making this rapid progress possible? 3 major breakthroughs. First, large language models, LLMs, like GPT-4, have transformed how humans and robots communicate. Optimus can now understand spoken instructions, ask follow-up questions, interpret context, and turn vague commands into specific actions. This solves one of the biggest challenges that held household robots back in the past. Second, although home environments are messier and more unpredictable than factories, they offer a goldmine of real-world training data. The everyday situations and human interactions Optimus encounters at home help train its AI to be more adaptable and responsive, just like how Tesla used real-world driving data to improve its full self-driving FSD software. Third, there's the power of the network effect. The more Tesla bots are out in the world, the more data they gather, and the smarter they become. Tesla can also afford to sell Optimus at a lower price by using profits from industrial robot sales, just like it did with early electric cars, to quickly build a data advantage in the household robot market. In short, the era of home robots is arriving much faster than predicted, and Tesla Bot Gen 3 is leading the way. It's not just a robot. It's the beginning of a revolution in how we live with AI in our daily lives. 4. Manufacturing, Tesla's secret weapon. When we first started researching this topic, we thought Tesla's biggest advantage in the robot race would be its world-class manufacturing capabilities. It made sense. Tesla builds over 2 million vehicles a year and pioneered the use of the massive gigapress, which can mold car body parts in just a few large pieces. This has cut production time and labor costs significantly. Even if someone else built a more advanced robot, Tesla's ability to scale production could still give it the upper hand. And that's still true, but the picture is more nuanced than we initially thought. Tesla's manufacturing expertise is undeniable. They've invested over $3 billion in automation, and their proprietary Tesla operating system helps manage the supply chain and robotized production. But manufacturing robots isn't quite the same as building cars. In many ways, it's simpler. A humanoid robot like Optimus stands about 173 centimeters tall and weighs only 56 kilograms. That's just 5% the size and weight of a Tesla Model Y. As a result, robot production lines are much smaller and more flexible. You don't need massive body presses, paint shops, or crash test facilities. In fact, an Optimus assembly plant could fit inside a space smaller than 5,000 square meters, while car factories often take up hundreds of thousands. Cars are also made up of over 10,000 parts, ranging from electric drive systems and batteries to air conditioning and infotainment tech. In contrast, a humanoid robot like Optimus may use fewer than 1,000 parts. These mostly include servo motors, circuit boards, sensors, a lightweight carbon fiber frame, and a compact battery under 2 kilowatt-hours. This simpler, more modular design drastically reduces the complexity of scaling up production and shortens the learning curve for mass manufacturing. We hope you found this video insightful and enjoyable. If it gave you something to think about, or just helped you relax, please give it a like and consider subscribing to Next Gen Theories. Hit the bell icon so you won't miss our future videos on Tesla, robotics, and next-gen tech. We truly appreciate your time and feedback. Thanks for watching, stay safe, and we'll see you in the next one.